Once again, good day everyone. So the discussion for today covers the sixth chapter of the lesson, and it's about the process selection and the facility layout. At the end of this chapter, we are expected to explain the strategic importance of process selection and the influence it has on the organization and its supply chain, to describe product layouts and process layouts and their main advantages and disadvantages, to solve simple line balancing problems, and to develop a simple process layouts. So we also have here the outline of topics that will be discussed. First is the process selection, the technology and process strategy, the strategic resource organization and its facilities layout, the designing product layouts, the line balancing, and last is the designing process layouts. So process converts input into output. So they are the core of operations management, but the impact of process selection goes beyond operations management as it affects the entire organization and its ability to achieve its mission, and it affects the organization's supply chain. So process selection has operational and supply chain implications. Operational implications include equipment and labor requirements, the operations cost, and both the ability to meet demand and the ability to respond to variation in demand. So process selection refers to deciding on the way production of goods or services will be organized. It has major implications for capacity planning, the layout of facilities, equipment, and designs of work system. So process selection occurs as a matter of course when new products or services are being planned. So this figure right here shows the forecasting, the product and service design, and technological change as inputs, and these three influences the capacity planning and process selection, which in turn affect the outputs, which are the facilities and equipment choices, layout, and work design. So how an organization approaches process selection is determined by the organization's process strategy, which includes these two aspects: the capital intensity, which refers to the mix of equipment and labor that will be used by organization, and the process flexibility, which refers to the degree to which the system can be adjusted to changes in processing requirements due to such factor as changes in product or service design, changes in volume processed, and changes in technology. So we have here the two key questions in process selections. First is how much variety will the process needed to be able to handle, and how much volume will the process needed to be able to handle. So the answers to these two questions will serve as a guide to select an appropriate process. So there are 5 basic process types. First is the job shop. So this usually operates on relatively small scale businesses. So it is used when a low volume of high variety goods or services will be needed. High flexibility using general purpose equipment and skilled workers are important characteristics of this process. So a manufacturing example of this process type is a tool and die shop that is able to produce a one-of-a-kind tools. And a service example is a veterinarian office which is able to process a variety of animals and a variety of injuries and disease. Next is the batch processing. So this is used when a moderate volume of goods or services is desired, and it can handle a moderate variety in products or services. So examples of this system includes bakeries, which make breads, cookies, or cakes in batches, and movie theaters, which shows movies to group or batches of people. So next is the repetitive process. When a higher volume of more standardized goods or services are needed, so this processing is used. The standardized output means only slight flexibility of equipment is needed. So automobiles, television sets, and computers are familiar products made by these systems. Another one is the continuous process. So when a very high volume of non-discrete, highly standardized output is desired, a continuous system is used. So these systems have no variety in output and hence no need for equipment flexibility. These process types are found in a wide range of manufacturing and service settings. So the ideal is to have a process capabilities that match the product or service requirements. So failure to do so can result in inefficiencies and higher costs than are necessary and would also create competitive disadvantages. The table on your left screen shows a summary of the 4 process types according to its description, advantages, and disadvantages. And the figure on the right side is the product or services and its volume and variety. So the last process type is the project, which is used for work that is non-routine, with a unique set of objectives to be accomplished in a limited time frame. So an example for this is putting on a play, consulting, making a motion picture, launching a new product or services, publishing a book, building a dam, and building a bridge. The type of process or processes used by an organization influences a great many activities of the organization. So this table shows how a process choice affects the numerous activities of an organization. So let's have the job shop as an example. So the cost estimation in job shop system is difficult. Its cost per unit is high. The equipment used is general purpose. The fixed cost is low. The variable cost is high. The labor skills is high. And the marketing promotes the capabilities. The scheduling in job shop system is also complex, and the work in process inventory in job shop system is high. So the product or service profiling. So this refers to the linking key product or service requirements to process capabilities. This can be used to avoid any inconsistencies by identifying key products or services dimensions and then selecting appropriate process. So the key dimensions often relate to the range of products or services that will be processed, the expected order size, the pricing strategies, the expected frequency of schedule changes, and the order winning requirements. Next is the sustainable production of goods and services. So business organizations nowadays are facing increasing pressure from a variety of sources to operate sustainable production of processes. According to the Lowell Center for Sustainable Production, a sustainable production is the creation of goods and services using processes and systems that are non-polluting, conserving of energy and natural resources, economically efficient, safe and helpful for workers, communities, and consumers, and socially and creatively rewarding for all working people. To achieve this, the Lowell Center advocates designing and operating processes in ways that waste and ecologically incompatible byproduct are reduced, eliminated, or recycled on-site. Chemical substances or physical agents and conditions that present a hazard to human health or the environment are eliminated. The energy and materials are conserved, and the forms of energy and materials used are most appropriate for the desired ends, and workspaces are designed to minimize or eliminate chemical, ergonomic, and physical hazard. Next is the lean process design. So one principle of particular interest here is the waste reduction, which relates to the sustainability objectives. So lean design also focuses on variance reductions in workload over the entire process to achieve the level production and thereby improve the process flow. So a successful lean design results in reduced inventory and floor space, the quicker response time and shorter lead times, reduced defect, rework, and scrap, and it increased the productivity.
So in this part of the discussion, we will be talking about technology. So let's define what is technology first. So technology, it refers to the application of scientific knowledge to the development and improvement of goods and services and or the processes that produce or provide them. Example in technology is, for example, machinery. It provides goods to the customers, so involve the ang technology. So next is technological innovation. This is a discovery and development of new or improved products or services or processes for producing or providing them. So this is a production of innovative products. So the more nag-high-tech atong kalibutan, the more nga nanggawas ang mga innovative products. Kay nagkakuan man, nagka-high-tech ta, nagka-high man ang standards sa nga mga gusto sa mga tao. And then next is high technology. The most advanced and developed equipment and or methods. Kaning high technology is kaning unsa may example niya, for example AIs and drones. So makita lang nimo ni siya sa mga dagko nga kompanya kay kaning high technology is dagko ni siya budget and it is also difficult to make. And then next is information technology. So information technology or IT is the science and use of computers and other electronic equipment to store, process, and send information. So for example, ani ang mga online platforms like mga online stores, mo siya mga kuan example aning IT. The next is process technology. So this includes methods, procedures, and equipment used to produce goods and provide services. This is not only involve processes within an organization but also extend to supply chain processes. Manong kuan man dili lang siya involved inside the organization. Kay kuan man involved man pud ang supply chains, which is ang supply chains it also involves logistics. So unsa man ang logistics? Ang logistics is kaning for example ani niya kay delivering goods to the customers or receiving supplies to the suppliers. So that is why nga dili lang yun siya sa sulod sa organization ginabuhat ang process technology. So in the process technology and information technology, it has a major impact on cost, productivity, and competitiveness. So ang first aning sa unsa may kuan, it can lower cost and it can also increase productivity. For example, ani kay ang sa mga kumpanya nga mga nag-use og mass production, di ba? Kali siya kay gamit pa siya og machine, so it can increase your productions of goods. Then kani siya, it can also gain competitiveness advantage because for example ani niya sa example sa kaning sa online platform ug sa mall, ang atong example niya is kaning sa clothing industry, di ba? Sa Shopee kay convenient ra man jud kayo imong pag shopping kay mag-scroll lang ka, maghida-hida lang ka sa balay without bothering anyone, or kaning sa kuan sa mall kay magkuan ra jud ka, magsayang-sayang pag PT, magkuan pa ka or magsayang-sayang kag gas, tapos magsayang-sayang kag energy kay mangita pa ka, mag-hike pa ka, mamili pa kag mga sanina. There are a lot of varieties of designs dito sa mall nga pamangitaon pa nimo, unlike jud sa online nga mag-search ka tapos manggawas na dito ang mga categories. Tapos that is why nga daghan ang mga to sa online platform kay mas convenient man siya, unlike sa kuan jud siya, imo jud siyang i-add to sa mall. And next is technological innovation in processing technology. It can produce tremendous benefits for organization by increasing quality, lowering costs, increasing productivity, and expanding processing capabilities. So kani siya pare sa akong gingon ganina nga pare sa to mass productions kay ga-involve man siya og machinery. That's why it can lower your cost, and there is it increase expand processing capabilities, diba? Kay mas kuan man jud ang machinery, sa machinery ka mag-base mas kuan man gud, mas daghan, mas flexible imong mabuhat, unlike jud sa dili ka maggamit og technology kay lisod na pud biya karon kay dili ka maggamit og technology kay murag dili nakaka-adapt sa world kay maglisod pa man gani ta og kuan gani og lihok na og dili na ta mag-use og phone, unsaon na lang og kanang naa na ka sa business industry. The next is automation. So what is automation? This is a machinery that has sensing and control devices that enable it to operate automatically. It can range from factories that are completely automated to a single automated operation, frequently touted as a strategy necessary for competitiveness. So sa example aniya, for example kaning iba mato kag groceryhan din namo jud ni mga barcode kani siya. For example aning barcode kay di ba kay naka-help man ni siya sa kaning sa grocery kay it will indicate to the system nga pila ang ma-procured nga or nakuha nga certain products. Kay di ba sa grocery kay daghan mag products jud, a lot of variety products mo na nga. For example ni kay ito ma-indicate nga pila ang makuha nga goods or quantity sa certain products, and that is why dili na jud sila maglisod sa if ever dito sa inventory management because of the system na nag-help sa ilaha. And then unsa may advantage aning automation? It has low variability, whereas it is difficult for human to perform a task in the same way, in the same amount of time, and on repetitive basis. In a production setting, variability is detrimental to quality and to meeting schedules. Machines do not get bored and distracted, nor do they go out on strike as for high wages or file labor grievances with the reduction of variable costs. So kani ang advantage niya ang machines kay kuan magud siya, di ba? Kanang automatic na jud siya. Then ang kung unsa ang na kuan dito sa program, kung pila ka pila ka products ang mahimo sa ana nga certain nga time, maura pud na ang mabuhat niya. Unlike sa kita nga mga human kay, for example, naman may time nga gana kita mo mulihok, tapos hatagan ta og limited time. So dili jud kanang exact nga kaning sani nga atong mahimo sa sa kanang naika-indicate nga gihatag nga time sa tua, ug pinampuy times pud nga wala tay gana, so gamay ra pud tag mabuhat. So kaning machine kay naka-program na jud siya daan nga kung pila ang ilang mabuhat sa a certain time. Then kaning machine pud kay human biyata. So for example, if dili ta kanang in favor sa benefits sa isa ka organization, kay we will go on strike. Unlike sa machinery sa wala jud sila brain, so dili sila ka-decide ug kuan, dili jud sila ka-decide. Then and ang kuan pod is it is detrimental to quality and to meeting schedules. So kani siya ang kuan jud niya is ang quality pod niya is exact jud pod kay naka-program na pod siya daan. And sa schedules pod nga ug unsa jud ang kanus amahuman kay naka-program man pod siya, dira ra pod siya taman. And then next is ang limitations niya. Unsa man ni iya mga limitations? It is very expensive and it is less flexible than human labor. So kita mga humans maka-decide ng taon sa jud atong buhaton, unlike sa machines which is controllable by computers. So kaning pong technology is, if ever jud magkuan kaning technology or mag-procure kaning mga machines, it will acquire a great cost jud. So next is three kinds of automation. So first is fixed automation. Unsa man ni siya? It is also known as hard automation. It uses high-cost special equipment for a fixed sequence of operations. So iyang advantage is low cost and high volume. Limitations is minimal variety and the high cost of making major changes in either product or processes. So kani siya is fixed lang jud ang iyang ginabuhat sa a certain sa technology. The next is ang programmable automation. Kani siya is involve the use of high-cost general-purpose equipment controlled by a computer program that provides both the sequence of operation and specific details about operation. This type of automation has the capability of economically producing a fairly wide variety of low-volume products in small batches. And the ano niya is ang computer-aided manufacturing. So kani siya kay an example niya is kaning mga AI. So kani the use of computer in process control ranging from robots to automated quality control. So kani siya kay control siya through sa computer. And next is numerically controlled machines, programmed to follow a set of processing instructions based on mathematical relations that tell the machine that the details of the operation to be performed. So sa example niya, for example ni kay ato lang example kabantay mo na kana sa, for example kana sa mga oven, di ba na may mga numbers dira sa kilid. So dira mora na ilang kay ang sa, di ba sa oven kay kuan makagpila ka time ang imong i-use para iluto imong foods. Pareha sa pud siya sa kaning sa mga machines nga ginagamit mag-provide og goods. Sa example, kuan ka dito pila ka buok ang imong ibuhat nga products sa gamit ang machine. Dayon next is ang flexible automation. So it evolved from programmable automation. It uses equipment that is more customized than that of programmable automation. Flexible automation requires significantly less change over time. So under niya is flexible manufacturing system. It's a group of machines that include supervised computer control, automatic material handling, and robots or other automated processing equipment designed to handle intermittent processing requirement with some of the benefit of automation and some of the flexibility of individual or standalone machine. For example, ano niya kay, 'di ba, kaning sa nabantay mo ni sa kaning in the process of making medicines, di ba? Kabantay mo ato mga kaning mga kamot nga mga robots. Mo na siya example sa flexible manufacturing system. Diyon. Next is computer integrated manufacturing. Kani siya a system that uses an integrating computer system to link a broad range of manufacturing activities including engineering design, flexible manufacturing system, purchasing, order processing, and production planning and control. Kani siya kay ang computer, example ang computer gi-connect sa isa ka technology, then dito ra ka maghatag og information sa computer, ka maghatag og information sa technology. For example, ani kay gusto ka you can use it nga magkuha og i-control nimo ang isa ka robot nga magkuha og gamit, tapos pwede nimo siya nga magkuan ka og kanang magpabuhat ka og pattern dayon. For example, magamit pud nimo siya sa kaning in planning and controlling. So mas flexible lang jud ni ang computer integrated manufacturing, unlike sa other categories. So its goal of using is to link various parts of an organization to achieve rapid response to customer orders and or product changes, to allow rapid production and to reduce indirect labor costs. Next is 3D printing, a type of industrial robot that is controlled using computer-assisted design. Known as additive manufacturing. Additive manufacturing involves processes that create three-dimensional objects by applying successive layers of materials to create objects. Ang benefits niya is offer an alternate form of production that provides value in a wide range of applications. Isa may example niya, for example, kaning mga sa cars, di ba, kay for us to kuanjud kanang makahimo og car, kay di ba gina-divide, dili man jud na iusa jud dayon pagkahimo ang gina-divide pa man na ang iyang naman jud na siya mga parts, ginahimo pa na siya ang parts, gilay-lahi pa na siya gihimo, dili na daritso og himo ang car nga isa na din na siya daritso. Gigamit ana ang 3D printing, na siya gigamit ana ang machine. Then for example, ani niya kay lagi mo to vehicles, then robots, dayon rapid prototyping. The next is drones. Unsa man ang drones? It is a remotely controlled unmanned aircraft, usually small. An important benefit is providing eye in the sky to obtain visual detail in places that are hazardous to humans or that are not readily accessible. Kani ang kabalo mo sa ang drone, pero na siya mga disadvantage pod. Ang disadvantage, for example, kaning mga flying objects nga, for example, nga mabanggaan ni din, example mahulog, then makakuan cause og, and also it is hazardous sa human. For example, kay maguba, then example na technical error, di ba mo na ang disadvantage sa drones. So I think that would be all. Thank you for listening and God bless.
Next topic, it's about strategic resource organization with its subtopic facilities layout. So layout refers to the configuration of departments, work centers, and equipment with particular emphasis on movement of work, may it be customers or materials, through the system. As in other areas of system design, layout decisions are important for three basic reasons. First, they require substantial investments of money and effort. Second, they involve long-term commitments, which makes mistakes difficult to overcome. And third, they have significant impact on the cost and efficiency of operations. The need for layout planning arises both in the process of designing new facilities and in redesigning existing facilities. The most common reasons for redesign of layouts include inefficient operations, accidents or safety hazards, changes in the design of products or services, introduction of new products or services, changes in the volume of output or mixed outputs, changes in methods or equipment, changes in environmental or other legal requirements, and moral problems. The basic objective of a layout design is to facilitate a smooth flow of work, material, and information through the system. Supporting objectives generally involve the following. To facilitate a attainment of product or service quality, to use workers and space efficiently, to avoid bottlenecks, to minimize material handling costs, to eliminate unnecessary movement of workers or materials, to minimize production time or customer service time, and lastly, to design for safety. So there are three basic types of layout. It is on the product layout. It is used to achieve a smooth and rapid flow of large volumes of goods or customers through a system. It is a layout that uses standardized processing operations to achieve smooth, rapid, high volume flow. So you can see on this figure, it is an example of a straight line layout. So the advantages of a product layout. It has a high rate of output, low unit cost due to high volume. The high cost of specialized equipment is spread over many units. Labor specialization, which reduces training costs and time and results in a wide span of supervision. Fourth, low material handling cost per unit. Material handling is simplified because units follow the same sequence of operations. Material handling is often automated. Fifth, a high utilization of labor and equipment. Sixth, the establishment of routing and scheduling in the initial design of the system. These activities do not require much attention once the system is operating. And lastly, fairly routine accounting, purchasing, and inventory control. So these are the primary disadvantages of a product layout. The intensive division of labor usually creates dull, repetitive jobs that provide little opportunity for advancement and may lead to moral problems and to repetitive stress injuries. Second, poorly skilled workers may exhibit little interest in maintaining equipment or in the quality of output. The system is fairly inflexible in response to changes in the volume of output or changes in the product or process design. Fifth, the system is highly susceptible to shutdowns caused by equipment breakdowns or excessive absenteeism because workstations are highly interdependent. Fifth, preventive maintenance. The capacity for quick repairs and spare parts inventories are necessary expenses. Sixth, incentive plans tied to individual output are impractical since they would cause variations among outputs of individual workers, which would adversely affect the smooth flow of work through the system. Next is the U-shaped layout. It has the advantages of more compact, increased communication among workers, increased flexibility in work assignment, minimizes material handling. So the second type of layout is the process layout. So process layouts are designed to process items or provide services that involve a variety of processing requirements. So it is a layout that can handle varied processing requirements. So the advantages of process layouts. The systems can handle a variety of processing requirements. Second, the systems are not particularly vulnerable to equipment failure. Third, general purpose equipment is often less costly than the specialized equipment used in product layouts and is easier and less costly to maintain. Fourth, it is possible to use individual incentive system. So for its disadvantages. First, in-process inventory costs can be high if batch processing is used in manufacturing system. Second, routing and scheduling pose continual challenges. Third, equipment utilization rates are low. Fourth, material handling is slow and inefficient and more costly per unit than in product layouts. Fifth, job complexities often reduce the span of supervision and result in higher supervisory cost than product layouts. Sixth, special attention is necessary for each product or customer, for example, routing, scheduling, machine setups. And low volumes result in higher unit costs than with product layouts. Seventh, accounting, inventory control, and purchasing are much more involved than with product layouts. So as you can see in this figure, it is a comparison of a product and process layout. So third type of a layout is the fixed position layout. It is a layout in which the product or project remains stationary and workers, materials, and equipment are moved as needed. It is used in large construction projects such as buildings, power plants, dams, shipbuilding and production of large aircraft and space mission rockets. We also have what we call the combination layout. It is combined elements of both product and process layout. It maintains some of the efficiencies of product layouts, maintains some of the flexibility of process layouts. And also we have this what we call the cellular layout. Layout in which workstations are grouped into a cell that can process items that have similar processing requirements. So in this figure, you can show the comparison of process and cellular layout. So there are techniques to facilitate effective cellular layout design. First is the single minute exchange of die. It enables an organization to quickly convert a machine or process to produce a different product type. Next would be the right size equipment. It is often smaller than equipment used in traditional process layouts and mobile. We have this group technology, the grouping into part families of items with similar design or manufacturing characteristics. Design characteristics include size, shape, and function. We have this service layout, often categorized as product, process, or fixed position layouts. It is on the degree of customer contact and the degree of customization are the two keys of factor in service layout design. If the customization is high but the contact is low, the layout can be arranged to facilitate workers and equipment. But if the contact is high but the customization is low, self-service is a possibility. But if the degree of contact and the need for customization are low, the core service and the customer can be separated, making it easier to achieve a higher degree of efficiency in operations.
Hello everyone, I'm gonna tackle about my part wherein it's all about the designing product layouts toward line balancing. The goal of a product layout is to arrange workers or machines or equipments in the sequence that operation need to be performed. The sequence is referred to as a production line or a symbol line. Yes, under sa line balancing, there might be a goal or mission towards employment or individual or workers and other equipment or machineries na kailangan i-sequence in line or in the use of line balancing para mas efficient, effective, and productivity ang ilang work environment or sa workstations. The process of deciding how to assign tasks to workstation is referred to as line balancing. So, ang usa ka workstation daw is referred siya sa usa ka line balancing wherein ang workstation is nanihanglan og arrangement, sequences, and other preferable nga evaluations or deciding towards equipment and people itself. Okay, and then the goal of line balancing is to obtain task groupings that represent approximately equal time requirements. And mostly jud ang line balancing is required ni siya or formulate ni siya time in every workstation or individuals nga kanid dapat nga time is inyo ning ma-occupy in a given units or stations or pila pod ilang kailangan i-produce sa ana nga time requirements. And also line balancing minimize the idle time along the line and result in a high utilization of labor and equipment. Okay. Line balancing is very efficient in terms of the labors and equipment that need to be operate under of a certain workstations. Okay, idle time occurs if task times are not equal among workstations. Yes, na possibility na idle time is may tabo if ang given nga time is not rarely equal, meaning ang substation o kaning substation is dili bitaw pareha, so na possibility ng idle time occur. Pero some stations are capable of producing at higher rates than others, og napod lagi daw ang mga urban station or workstation nga gahatag yun og mas gahatag sila higher nga rates sa other nga workstation or gahatag sila dako nga favorable sa ana nga workstation than those other workstations. In a sense nga pwede na to siya ma-term as unbalanced lines wherein unbalanced lines are undesirable in terms of inefficient utilizations of labor and equipment, and because they may create moral problems at the slower stations for workers who must work continuously. Imbis na mag-work sila continue until mahuman nila ilang defined task on a specifying day, ma-less ilang productivity towards sa unbalanced lines na encounter sa individual and also occupying equipments. But in general sense, lines that are perfectly balanced will have a smooth flow of work. Yes, if it defined well or organized well, the work of individual are smoothly flow, as activities along the lines are synchronized to achieve maximum utilization of labor and equipment. Okay. Line balancing involve assigning tasks to workstations that usually each workstation has one worker who handle all of the tasks at that certain stations. Although in a sense, in every single stations there are always several workers. And now the question is, how does a manager decide on how many stations to use? But before that, we're gonna tackle about the line cycle time, wherein it is a primary determinant, where the cycle time is the maximum time allowed at each workstation to perform assigned tasks before the work must go on. And also, cycle time establish the output rate of a line. Okay, let's have this illustration example. Suppose that the work required to fabricate a certain product can be divided up into 5 elements tasks, with the task and precedence relationship as shown in the following diagram. So you have 0.1, 0.7, 1 minute, 0.5, and 0.2. Okay, the task times govern the range of possible cycle times, wherein the minimum cycle times is equal to the longest task time. So unsa may pinaka mas longest time ani out of this 5? Di ba natay 1 minute? So mo na siyang longest time, so mo na siyang gikuha. So and then the maximum time is equal to the sum of task time. So kanang 5 is imo na siyang i-add mo na din na imong maximum cycle time. So you will derive is 2.5 minutes. And then the minimum cycle that would apply if there were 5 workstations, while in maximum cycle that would apply if all tasks were performed at a single workstation. The minimum and maximum cycle thing are important because they establish the potential range of output for the line, which we can compute using the following formula. So ang formula is output is equals to operating time per day all over the cycle time. So let's assume that the line operate for 8 hours per day. So with a cycle time of 1.0 minute, output would be so kanang 8 hours. Imbis nga 8 hours imong ibutang diya, i-convert nimo siya into minutes kay ang imong gi-divide is 1 minute man. Di man pwede ang kuan 1 hours kay minute man imong gikuan. So i-convert nimo to minutes, so na kay 480 minutes. So in that case, imong i-divide ang 480 minutes sa 1 minute, so na kay makuha ang 480 units per day. While diri sa single time nga 2.5 minutes, imo siyang i-divide yapon sa atong 8 hours, which is 480 minutes, makakam up kag amount nga 182 units per day. And then kung imong tan-awon ning duha, mas dako og outcome or output ang kaning minimum time nga 0.1 per unit. Okay. But in reverse, if you will going to compute the cycle time, you're gonna use this formula, wherein the cycle time is equals to operating time per day all over the desired output rate. So ang desired output rate ni man is 480 units. Cycle time is equals to 480 minutes per day all over the 480 minutes per unit. That will equivalent to 1 minute per unit, and that 1 minute is your cycle time. Line balancing, we can use this formula or method wherein the number of workstations that will needed is a function of both the desired output rate and our ability to combine elemental tasks into workstations. We can determine the theoretical minimum number of stations necessary to provide specific rates. So in this case, we were gonna formulate or known on how many stations should be acquired or implied. So by using this formula, wherein theoretical minimum number of station equals to the sum task of times all over the cycle time. So let's have an example. Suppose that the desired rate of output in the maximum of 480 units per day. That in the sense that this will require a cycle time of 1.0 minute. The minimum number of stations required to achieve this goal is theoretical minimum number of stations equals 2.5 minutes per unit all over the 0.1 minutes per unit per stations. That will equal to 2.5 stations, but 2.5 stations is not defined as kuan jud kani mo na gyud ang total stations na iyang magamit, kay since na 0.5 pwede na to na siya ma-round off para manon yun na to, it's either tura ba siya or mo pataas pa siya. But since 5 siya, there is possibility nga ang equivalent sa station nga pwede ma-acquire or magamit is 3 stations. Okay, and the next is we will gonna know about the measure of effectiveness that classified into categories: the percentage of idle time of the line and the efficiency of the line. Wherein the percentage, you can just use this formula: the percentage of idle time equals to the idle time per cycle all over the actual number of stations times the cycle time times the 100, wherein the n actual is the actual number of stations. While in the efficiency, you can just use this formula. After knowing the percentage of idle time, you can just deduct the given percentage, which is the 100%, or you can use this formula instead. Efficiency equals the actual number of stations times the cycle time minus the idle time all over the actual number of stations times cycle times the 100. In that case, you will get the efficiency of the line, or compute or know the efficiency of the line. In this case, after knowing its rate and cycle time using these two methods of measure of effectiveness, we can consider whether the selected level of output should equal the maximum output possible, while the minimum number of workstation needed is a function of the desired output rate, and therefore the cycle time is occur. Some guidelines for line balancing. In line balancing, a symbol line tasks are assigned one at a time to the line, starting at the first workstations. At each step, the unassigned tasks were decided to determine which are eligible for assignment. Also, technological constraints tell us which element tasks are eligible to be assigned at a particular positions on the line. Technological constraints can result from precedence or ordering relationship among the tasks. Output constraints, on the other hand, determine the maximum amount of work that a manager can assign to each workstation, and this determines whether an eligible task will fit at the workstations. Once it is known which tasks are eligible and will fit, the manager can select the task to be assigned. This is where the realistic rules help us decide which task to assign from among those that are eligible and will fit under in the guidelines of line balancing. The parallel workstation, it defined as an increase of workflow and provide flexibility wherein the number of rates and amounts of time in each given task. We also have other approaches to achieving a balanced line. First one is the cross-train, sometimes referred to as a dynamic line balancing, and it is widely used most often in line production system. Also, in line with workers or our employees, they could also able to perform more than one task. Yes. While in the other hand, mixed model line is to design a line to handle more than one product on the same line or task, wherein in this model offer a great flexibility in varying the amount of output of the product. And that would be the end of my part, and let's proceed to the next topic, which is the
Designing process layouts. The main issue in designing process layouts concerns the relative positioning of departments involved. The problem is to develop a reasonably good layout. Some combination will be more desirable than others. For example, some departments may benefit from adjacent location, whereas others should be separated. A lab with delicate equipment would not be located near a department that had equipment with strong vibrations. Conversely, two departments that share some of the same equipment would benefit from being close together. Layout can also be influenced by external factors such as the location of entrances, loading docks, elevators, windows, and areas of reinforced flooring. Also important are noise level, safety, and the size and location of restrooms. In some instances, a sufficient number of installations having similar characteristics justify the development of standardized layout. For example, the use of the same basic patterns in McDonald's fast food, location, facilities, constructions of new structures, and employee training. Food preparation, order taking, and customer service follow the same pattern throughout the chain. Installation and service of equipment are also standardized. This same concept has been successfully employed in computer software products such as Microsoft Windows and the Macintosh operating system. Different applications are designed with certain basic features in common so that a user familiar with one application can readily use other application without having to start from scratch with each new application. The majority of layout problems involve single rather than multiple location, and they present unique combination of factors that do not lend themselves to standardized approach. Consequently, this layout require customized design. A major obstacle to finding the most efficient layout of department is large number of possible assignment. For example, there are more than 87 billion different ways that 14 departments can be assigned to 14 locations if the location form a single line. Different location configuration. 14 departments in a 2x7 grid often reduce the number of possibilities as do special requirements. The stamping department may have to be assigned to a location with reinforced flooring. Still, the remaining number of layout possibilities is quite large. Unfortunately, no algorithm exists to identify the best layout arrangement under all circumstances. Often, planners must rely on heuristic rules to guide trial and error efforts for a satisfactory solution to each problem. Measure of effectiveness. One advantage of process layouts is their ability to satisfy a variety of processing requirements. Customers or material in this system require different operations and different sequences of operations, which causes them to follow different paths through the system. Material-oriented system necessitates the use of variable path, material handling, equipment to move material from work center to work center. In customer-oriented system, people must travel or be transported from work center to work center. In both cases, transportation cost or time can be significant. Because of this factor, one of the major objectives in process layout is to minimize transportation cost, distance, or time. This is usually accomplished by locating departments with relatively highly interdepartmental workflow as close together as possible. Other concerns in choosing among the alternative layouts include initial cost in setting up the layout, expected operating cost, the amount of effective capacity created, and the ease of modifying the system. In situations that call for improvement of an existing layout, cost of relocating any work center must be weighed against the potential benefits of the move. Information requirements. The design of process layout requires the following information. First, a list of department or work centers to be arranged, their approximate dimensions, and the dimensions of the building or building that will house the departments. Second, projection of future workflows between the various work centers. Third, the distance between location and the cost per unit of distance to move loads between locations. Fourth, the amount of money to be invested in the layout. Fifth, a list of any special consideration, example, the operations that must be close to each other or operation that must be separated. The location of key utilities. Number 6. The location of key utilities, access and exit points, loading docks, and so on in existing buildings. The ideal situation is to first develop a layout and then design the physical structures around it, thus permitting maximum flexibility in design. This procedure is commonly followed when new facilities are constructed. Nonetheless, many layout must be developed in existing structures where floor space, the dimension of the building, location of entrances and elevators, and other similar factors must be carefully weighed in designing the layout. Note that multi-level structure pose special problems for layout planners. Minimizing transportation costs or distances. The most common goal in designing process layout are minimizing of transportation cost or distances traveled. In such cases, it can be carefully to summarize the necessary data in from to charts like those illustrated in tables 6.6 and 6.7. Closeness ratings. Although the preceding approach is widely used, it suffers from the limitation of focusing on only one objective, and many situations involve multiple criteria. Richard Mother developed a more general approach to the problem, which allows for subjective input from analysis or manager to indicate the relative importance of each combination of department pairs. That information is then summarized in a grid like that shown in figure 6.12. Read the grid in the same way as you would read a military chart in a road map, except that letters rather distances appear at the intersections. The letters represent the importance of closeness for each department pair, with A being the most important and X being an undesirable pairing. Those in the grid, it is absolutely necessary necessary to locate 1 and 2 close to each other because there is an A at the intersection of those departments on the grid. On the other hand, 1 and 4 should not be close together because their intersection has an X. In practice, the letters on the grid are often accompanied by numbers that indicate the reason for each assignment. They are omitted here to simplify the illustration. Mother suggests the following list. First is they use same equipment or facilities. Second, they share the same personnel or records. Third, required sequence of workflow. Fourth, needed for ease of communication. Fifth, would create unsafe or unpleasant conditions. And lastly, sixth, similar work is performed.